So I'm down in my workshop, getting a bit frustrated because I always forget to turn on my dust collector. I have a dust collector and it's hooked up to my machines, but I always forget to turn them on. So I'm thinking what I can do about that. I want some automatic system to turn it on when I start the machines. So I'm thinking to use a current coil. And this coil obviously needs to go on one of the wires. So I have to figure out where I should put it, if I put it centrally or for each machine. But then I will sense the current. And when I turn on the machine, I can use a small Arduino to activate my dust collector. And I'm thinking about maybe using a Shelly plug to start the dust collector. So I will be doing some testing with that, but I also have another plan if that doesn't work. So I will try a couple of theirs and see what works best. But in the end I want the dust collector to turn on automatically when I start any of my machines. So put an Arduino Nano on a breadboard, and I prepared resistors and capacitor. I will show the schematics later on, and connectors for the current coil. So, but first I will just test to see if I can control the Shelly plug. So to get started, I just created a small Arduino program. Still using the Arduino 33 IoT devices that has built-in Wi-Fi. So first of all, I'm using the Wi-Fi library, and here I'm setting the IP address of the Shelly plug that I'm going to be using. And go down to the setup. I'm starting the network connection to my Wi-Fi. And then I also have a loop here to retry the connection if it gets lost or something. And then small test, turning off and on the dust collector plug, which I called it. It will be the Shelly S plug. So if we have a look at the actual function, just created it quickly here. I see that some unneeded things, but basically we're connecting, making sure we're connected to the network, and then we are sending the command for turning off the relay in the Shelly plug and turning on the relay. So it's really simple since it's all parameters on the URL, and just using a get function to do that. And then we have the rest here is header information for the call, the REST call. And then I'm also receiving the response from the Shelly plug. So just let's see if this works. We'll download it. Start the monitor. Connected to Wi-Fi. I'm also reading the analog value because that's where I will detect this. And now we can see connecting to Shelly plug. You can actually hear it turning on and off. It's really nice. So next will be to make sure I can read the analog value from the current coil, and I'm actually going to have several current coils for different machines in my workshop, and if any of them turns on, I will turn on the Shelly plug, meaning the dust collector,
and then I will turn it off when the machine stops again. So let's continue with that.
So I've connected the current coil, and it needs to be connected to just one of the wires of your load. So I will see how to do that in the workshop later. Now I'm just testing, so I connected a hairdryer to get a bit of a load that is comparable to my machines. So next thing will be to test this.
So continue with the Arduino code. I've now connected the current coil to the analog input on the Arduino. And by experimenting, I found that when the analog value goes below 760, that's a good time to turn on the dust collector. So that's what I'm doing here. I'm turning on. I'm actually making sure that it stays stable for at least half a second, and then I turn on the dust collector with this command. And then when it stops, meaning that the analog value is higher again, then I will wait for approximately 20 seconds. I will see what's makes sense before I actually turn off the dust collector, so it doesn't keep turning on and off as I used the machines. So let's see if we can get this to work. I'm actually using a hairdryer as my load right now, just to see if it works. We'll download it. It's running. Connect it to the Wi-Fi, and let's test with the hairdryer. And you can see in the debugger here that it was turned on. You could actually hear the Shelly plug turning on as well. And now it's turned off again. I think that will work nicely.
So it's a new day, and I'm down in the workshop. I've been thinking a bit about my idea to use Shelly plugs for the dust collector. Some of you have already figured it out, I guess. I'm gonna run into problems since I have a security switch, a safety switch on the dust collector. So it will not be as easy as just putting this plug into place. So I had two options. Actually, I considered to use this one both in this end and on the machines, on the saws, because this one can monitor the energy consumption. So I can actually have an Arduino read the consumption of the machine and then send a signal to another one that I will put on the dust collector. But that would mean that I have to remove the safety switch on the dust collector. So I scratched that option. Instead, I will be using, or at least testing, a solid state relay. I will put that in series with the safety switch. And that means that I can still use the safety switch for turning on and off. And then I have this as an extra switch. That will mean that I will need to have an extra power on button as well, but I think that's okay. Or I can just have a switch that will bypass this one. I think that's actually what I'm going to do. So I will test this. This will also mean another advantage. Since I will be using the current coils on the machines, I actually will not need any Wi-Fi on my Arduino. I can make this completely without the Wi-Fi, and just another thing that can go wrong, so it will be more reliable if I don't use that. So what I'm going to do next is test this one. So I will hook this one up. It's a solid state relay. It can be operated with 3 to 32 volts. and that's fine for the Arduino, and about 10 milliampere I think. So that will, and it's actually rated for 40 amps, so it's way off what I need, since the dust collector is only 500 watts, so that should be fine. So I will just connect some temporary cables here. That, and then I will use just 9-volt battery to operate the switch. So let's see. I don't know if you can see it. So here's the safety switch. It's a magnet that will release when the power is lost, so it turns off. And it's rated for 16 amps. And I think we're gonna take the lead from the motor. This one. Remove that. I will connect my solid state relay. That. So the power is on, and to even be able to operate it, since it's in series, I will have to push this one. You can hear it click, so it's on. And then we try to apply 9 volt. And then start it again. And then the safety switch works, of course. So I think we'll build some box, and then I will put in bypass for the solid state relay, so I can turn on and off if I want manually. And then I connect the Arduino to that, and then I will use the coils for sensing the machines when they turn on. So my incoming power is here. It's a 3-phase coming in, and actually one or two of the phases, one go to my saw here, and the other one goes to the outlets above this saw. So my thinking is that if I hook up the current coils here, I only need 2 of them. And since all my heavy machines are on those 2 phases, and the 3rd phase is used for normal hand machines, hand tools, and then I don't want to start a dust collector. So if I put them on the 2 phases, that should be fine. And I don't need to have it on every single machine. It will detect it anyway, so I think that would work fine. So I want to know the current consumption of the solid state relay. So I connected it to 5 volt right now. and it seems to be around 8 milliamps. So I could actually drive it directly from the Arduino output. So depending if I'm going to use a 5 volt or 3.3 volt Arduino, see if 3.3 volt is 4.8 milliamps, so even less. And it should be okay.
So let's have a look at the final schematics. I'm using the Arduino Nano, so not the IoT with Wi-Fi. Since I skipped the Shelly plug, I don't need any Wi-Fi and don't need it to be connected in any way, so I can use the cheaper one. This is a 5 volt Arduino as well, and that works fine in this case. I will just drive it with a USB adapter, so that's simple enough. I put in 2 current coils, so I can monitor 2 phases. They have built-in load resistors, so the only thing I really need is a voltage divider. Here, 2 10K resistors and a capacitor to stabilize it a bit. And then I'm monitoring the voltage that goes into the analog converters in the Arduino. And it's not any precision measurement, and I don't really need that. It's just to give me a threshold for the turn on and turn off. And then I hooked up the solid state relay, and I'm actually driving it directly from the Arduino. Since it's only required 8 milliamps, it's no problem to do that. And then I put in my 2-way switch here to be able to bypass the solid state relay completely. So when I'm in bypass mode, the dust collector will work as normal, and I can turn it on and off with a safety switch, and the current will just flow through here. And in the on position, it will go through the solid state relay, and I can control it by my logic here.
So I have 3D printed box. I put in a switch so I can bypass the solid state relay. It goes here. So, after a bunch of connectors later, I managed to finish it. These 2 will go into the safety switch on the dust collector. So I want to put the Arduino here in this box. So that's why I'm cutting the wires here. So I put the Arduino on a board, made connections for the coils and also for the at the top here for controlling the solid state relay to the dust collector. So I will mount this in this same box. So the solid state relay is also connected with the same wire, and it goes through the workshop down to the 3-phase connection here. So here's the switch for the whole shop, and then I have just opened up the cable that goes to the central or the incoming. So the first test is not a success, as you can hear. The dust collector is running. You can see from the debugger that I'm just getting a high signal all the time on the analog read, and I know why. I forgot to connect the ground. So this is the connection for the coils, and they all go together here, and they should go down to the ground on the Arduino, and it doesn't, so let's fix that. Okay, so that mistake is fixed. And another mistake here. I decided to change the polarity, so I initiated it as high, and that would mean that it would be on. So since I changed the polarity, I need to change the initiation of the dust collector to be low. That means off. And since I now corrected the measurement, it should also be able to turn on again. So that was the reason it was actually on all the time here. So let's see. At least the dust collector is silent. Hopefully that means it works. And if we move to the dust collector, I made it so that this switch means that I'm using the automatic on off or not. So now it's enabled, but I still need to activate the security switch. That shouldn't really happen. So attempt number 3, I actually forgot to download a code, and that it's hard to get it to work if you don't do that. Oh, it stays quiet, and I heard it switch on. So Slates is working that, and the solid state relay is not on. Perfect. Let's try this one. Maybe it's turning off a bit too quickly. Might want it to run a bit longer. Maybe, I think it's 15 seconds now, maybe 30 seconds would be okay. Next thing would be to have automatic ports here for the dust collection. So it can select the right one. Maybe in the future. So I'm happy with this.
So I had to make a minor change in my schematics. Since we are dealing with alternating current, it was not a good idea to just read the analog value once or twice. You probably figured it out, but if I read it at the wrong position, I will get a higher value or lower value or a zero value. So I need to sample it basically. So what I'm doing now is that I'm sampling it 200 times, just reading the analog values 200 times, and I'm taking the lowest value that I can find, and I'm comparing that to my threshold value. So that's the part up here, and then the rest is basically the same, depending on the threshold value. I will turn on or off the dust collector.
So mounted it on the side, and I even printed a lid for it, my 3D printer. Unfortunately, I forgot to have somewhere to screw the lid on. So thanks to super glue. Well, I guess I probably never get it off. Hopefully it will work. So the main switch is on for the shop. And here's the coils and the Arduino. Power supply with a USB. The wire goes around, well actually that way, around the shop and to the dust collector. I guess the lid is permanently there. We'll never be able to take that off. I'm really happy that I could keep the security switch, and if I switch this one up, it is normal operation. Can just turn on and off as I want. And if I put the switch down, I still need to turn it on, the security switch. You can hear it click, and now I can use it with my machines. You can hear the dust collector running for 15 seconds, I guess. And now it's off. Mission completed. Very happy with that.